Hi everybody, welcome back. Today we're going to do our last video on quadratics. It is about word problems. Just checking the calendar right now. Is that really true? Yeah, last video on word problems. That's happening. So, word problems actually, there's not a lot of questions they're going to ask you about word problems. There's like maybe 3 or 4 total, which are very, very easy to understand. So, today in our notes, what we're going to do is basically go through all those questions and what it means mathematically and how to find them, okay? Now, in the notes, it shows you how to do it in the calculator, or rather, it reminds you how to do it in the calculator. And then, but all the work that I'm going to show you is by hand, because like I said in class, calculator is to help you after you have done the understanding. It is not an alternative to you having to understand it, okay? So, we're going to go ahead and do it by hand today, but let's go ahead and get started. So here's the formula you're typically going to see is like y equals or h equals or something. Some negative number, because a lot of our parabolas that we're dealing with are talking about going up in the air and coming back down for our word problems. You might see one going like underwater, like going down and back up to the x-axis, which would be like going underwater, below sea level or something like that, or underground. But yeah, you still do it the same way. But again, majority of the time you're going to have like a negative number in the front because it is a parabola opening down. Okay? So it could be like negative 16, negative 12. It doesn't really, I mean, it has some meaning to it, but not much. The next part, your B term though. Your B is actually representing your initial upward velocity. Okay? That is a physics thing, not a math thing, so I'm not sure what, like, I mean, we could calculate it, but that is not an algebra thing, so just know that it's your initial upward velocity. And then the H at the end, your C term, that's your initial height. So where is this ball starting? Is it starting like off of a roof? Is it starting from the ground? Is it a rocket being launched off the ground? Is it like, is the ball being thrown from your hand and you're like 5 feet tall? Those are the different, like, where is it starting at? Like, how tall, like, how high is it starting from? That's your initial height. And that's still your y-axis on your y-intercept on the graph, okay? So, that could be a question they ask, like, how tall was it? Where did it start? At what height did it start? And stuff like that, okay? So, just, that's something just to know. It's not super necessary, but it's good to know, okay? So, let's go ahead into the kind of questions they'll ask. So, first one would be like, how long is the ball in the air? How long did it take until it hit the ground again? Well, if you think about it, that's basically the entire length of the parabola. So you throw it up, it goes all the way to the height that it can, and then it comes back down, right? So we're figuring out how long it took from starting off. Sorry, it's at the end of the day, and announcements are going on. Sorry. So, but... Maybe. Wait 1 second. Okay, so basically when it's asking how long it's in the air, well, from when it started on the ground to when it ended on the ground. So when it's hitting the ground, that's our x-axis. Okay? So we're finding the zeros or the roots or the solutions or the x-intercepts when they're asking about how long. Because our x values are representing time typically, and our y values are typically representing height, okay? Depending on the situation. So, to find those, you can graph it, you can solve it by hand using, what is it called, factoring, or you can use quadratic formula, okay? And in the graphing calculator, you just go put it in your y equals, and then go figure out the zeros from it, and you can get the zeros that way too, okay? So that's one question. If they're asking how long it takes, they're asking for the zeros of the function. The maximum height is actually going to be the y value of your vertex. Remember, your vertex is going to be the highest point of the entire parabola, or the lowest, but for right now, our sake, when we're talking about this kind of stuff, it's typically the highest. So how long did it take for it to get to the maximum height? Well, the maximum height is going to be at that vertex. That's the highest point it is, and remember, your y values are your height. So we're just trying to basically find out what the y value is for our minimum or maximum, which is our maximum here. So you can go to the calculator, you can calculate the maximum, or Remember, to find the y value of the vertex, you'd have to calculate the negative b over 2a. That'll give you the line of symmetry, which is also the x value of your vertex. And then you would just take it and plug it back in. Okay? So, how long did it take to reach the maximum height? That's looking at what is the x value when it is there. Remember, time is your x value. So that's just calculating the line of symmetry, the negative b over 2a. So again, you can go to calculate your max in the calculator and just write down the x value. Same thing with what is the maximum height. You can calculate the maximum in your calculator and just write down the y value. Okay? And then how high after so many seconds? So they might tell you after in 3 seconds how high was the ball or something. Or after 0.5 seconds how high was the ball. Well, if you're looking for the height to find the y coordinate at a given x, you could just go to the calculator. You can actually go to trace and then value and type in your x value. It'll give you the y value. Or you could just plug in the x value into the equation, which will always be given to you, and solve for the y, just like if we were solving for the height of the vertex. Okay? So those are basically the 4 kind of questions they'll ask you, and that's it. Okay? So let's do some examples. Example 1, you're standing at the park and you kick the ball straight up in the air. The ball travels, not the park, at an initial velocity of 64 feet per second. It's just showing you why it's in there. The equation is h equals negative 16t squared plus 64t. So here h is representing your y and t is your x. And the height of the ball, h, is in feet because we're talking about feet per second. And the time is in seconds because we're talking about seconds. So here's a very crude picture of it, but here's a better graph of it. Okay? So you can see the actual thing. How long will the ball be in the air? Well, that's asking about your zeros. So if you want to do it in the calculator, which you can for SOLs, but not for your test. I need to see your work for your test, okay? Calculator can be used as a checking tool, but not as a doing tool, okay? So we're calculating the zeros. Clearly we can see what the zeros are. It's at 0 and 4. So we know what our answer should be. Now let's make sure we can work it out. Okay? So what you can do, since there are only 2 terms, it's not really that great, but it's 2 terms. We can go ahead and put it into the, what is it called? Quadratic formula. So we're going to fill in our a, b, and c, where a is negative 16, b is 64, and our c, which is non-existent here, is 0. So we go ahead and plug it in. Where did I write this? There it is. Sorry it's really small, but I need to fit a lot into a little space. So we get negative 64 plus or minus, that should be a plus or minus, but the minus, it's under there, you just can't really see it. Plus or minus the square root of 64 squared minus 4 times negative 16 times 0 all over 2 times negative 16. Negative 64 is 4,096, and then the negative 4 times negative 16 is positive 48 times 0, which is 0, so you just have the 4,096 under there. Take the square root of 4,096 and put it over negative 32. You get negative 64 plus or minus 64 over negative 32. So that's where you're going to split it. So you can do plus first. Negative 64 plus 64 is 0. 0 over negative 32 is just 0. That's actually where our ball started, at 0 height, at 0 seconds. So when we hadn't started the timing yet, it was on the ground. It was at 0. Okay? And then we do it with the minus. So where is the minus part? There it is. Then we have negative 64 minus 64 over negative 32. That's negative 128 over negative 32 gives me 4. So when it hits the ground again, that was after 4 seconds. So that was our finish time. Okay? So the total amount of time it took, by the way, this is the height. This is the time. It took 4 seconds total for it to go up in the air and back down. Okay? When will the ball be at its maximum height? So that's right here. That's the maximum height. So we're not looking for the x value because that tells me, oh, we are looking for the x value because it's when. I did this again. So we're looking for the x value, which we can tell is 2. But here's how you do it algebraically. We go for the line of symmetry because that's what that maximum height is going through. So we're just going to calculate this, negative b over 2a. That's negative 64 over 2 times negative 16. So we get negative 64 over negative 32, which comes out to be t equals 2. So 2 seconds is our answer. Okay? So we're trying to find the time for the vertex. And how high does the ball get? Well, that's our y value, because that's talking about the x, or the h. So we're going to take our line of symmetry, because we have the x value for the vertex, and we're going to use that to find the y value for this vertex. So we're going to go ahead and start with our equation, which we started up at the top. And we're going to, instead of t, we're going to plug in 2. So negative 16 times 2 squared plus 64 times 2. We go ahead and do that. So that's negative 16 times 4 plus 64 times 2. Negative 64 plus 128 gives me something, where'd it go? 64 feet. That's how high it went. That's a big kick. Good job, whoever kicked that ball. Okay? So, not too bad. A lizard is jumping across the water in search for food. The equation h equals negative 12t squared plus 6t models the lizard's height, h in feet, and above the water, t seconds after he jumps. So we're doing seconds and heights. Here's the lizard. Here's actually the model for it. So here's where he's starting. This is at 0 time. He's going to start at the ground, and he's going to jump up. Over time, he's going to come back down, and that's where he's going to hit again. So how long after jumping is he back on the water? So again, we're looking for the... Come on! Oh, none of this stuff is working. Oh, this is going to be so annoying. So annoying. Oh, gosh, guys. I'm going to be so pissed the entire time. And there's nothing I can do about it. Okay. Sorry. Technical difficulties are the worst. None. Oh my gosh, this is going to take forever. I'm sorry, guys. Why don't you guys go ahead and try this on your own? Because it's exactly the same way as what we just did. And see how far you can get before I actually am able to get this working. Which is going to take a few minutes. And I don't want to stop. Oh yeah, I'll go ahead and stop it. So, okay, when I come in the second after I stop this thing, I'm going to start up again. So it's not going to be any transition for you, but it will be for me. Okay? See you in... Okay, sorry about that. So now I'm back, and it's all working. Now, this is probably going to look weird because it was blank screen before. So here's all the stuff, because I couldn't get the fade in, fade out stuff to work. Here's the issue. Please, I urge you very, very much to actually listen to what I'm saying and not just write it all down, because if you don't know why it's there, then it's not helpful to you. Okay? So, the first question asked, how long after jumping is he back on the water? Or, like I said, we're trying to find the zeros. Okay? So here we have h equals negative 12t squared plus 6t. Well, our whole thing that we're supposed to do when we... First thing we need to do is factor so we can get the zeros. We set it equal to 0. Right here. We set it equal to 0, but we need to factor it. Now, Magic X could work. However, there's an easier way. GCF. These two have something in common. They actually have a 6t in common. They have a negative 6t in common. So I pull that out. I get negative 6t and 2t minus 1. Those are my two factors. I can't factor them anymore. So those are the things that I'm setting equal to 0. So negative 6t equals 0. I solve for t. T equals 0. So that's where he started at. That was the time, how long it took for him when he wasn't in the air. Like he started at 0 seconds. Here, 2t minus 1 is my other factor. I set that equal to 0. I'm going to add 1 to both sides first and then divide everything by 2. So t equals 1/2. So he comes back to the ground, or the water, after half a second. That's where he finishes. So it took half a second for him to come back to the water. Second question, how high is each jump? So here's how high it is. We're looking for the vertex. They're asking for the height, so that's the y value. Okay? In order to find that, we need to know what the vertex x value is. So first, we need the line of symmetry. So we go ahead and find the line of symmetry. Negative whatever b is, which is 6, over 2 times a, negative 12. So we multiply that, so we get negative 6 over negative 24. It's going to take him 1/4 of a second to get to his maximum height. And at that time, we can figure it out just by plugging in. When we have the time of 1/4, we put it in for t. Negative 12 times 1/4 squared plus 6 times 1/4. Well, 1/4 squared is actually just 1/16. And we multiply that by negative 12, we get negative 1, or 3/4. 6 times 1/4 is 6/4. They have the same base, so we can go ahead and add or subtract their numerators. Not base, they have the same denominator. So negative 3 plus 6 gives me 3, all over the common denominator of 4, so 3/4 of a foot, or 8 inches, however you want to write it. Okay, you could put 0.75 feet, that's fine. But that's the y value. Now here, C asks how long did it take to get to the highest point? Well, we already found that out. That's the x value of the vertex. So literally, it's right here. The negative b over 2a, so negative 6 over 2 times negative 12 gives me negative 6 over negative 24, 1/4 seconds. That's how long it took. Okay? Alright, some more. Hopefully this works. Yeah, it's working. Okay. You and some friends went to a haunted house on Halloween, and Mommy scared one of your friends so much that she jumped into the air. The equation h equals negative 4t squared plus 2t models her jump when h is her jump's height in feet and t seconds after the mummy scares her. How long will it take your friend, how long was your friend in the air? Again, that's a 0. So she starts at 0 height, at 0 seconds, and then she goes up and back down. How long did it take her to get back down? We're looking for the zeros when she's actually on the ground. So, however you want to do it, you can do quadratic formula, you can do it from the graph. Graph's kind of iffy, so you'd have to do it in the calculator. This is what models her jump, though. And then, or you could do factoring. Again, they have a GCF in common. They have a negative 2t. So you set it equals 0, take out negative 2t, you get 2t minus 1. Set each equal to 0. Negative 2t equals 0, it's going to equal t equals 0 there. 2t minus 1, you add 1 to both sides and then divide it by 2. You get t equals 1/2. So she started at 0 time, and then she got back down there at half a second. So it took her half a second to get back down to the ground. How high did your friend jump? So that's, again, your y value for your vertex. So you need to know what the x value is for the vertex. The line of symmetry will help you do that. So negative b over 2a. That's negative 2 over 2 times negative 4, which is negative 2 over negative 8, which again is 1/4. Knowing that it takes 1/4 seconds to get to that height, you can plug it in and find out the actual height. So you plug it in, negative 4 times 1/4 squared plus 2 times 1/4. 1/4 squared is 1/16. Negative 4 times negative 4 times 1/16 is negative 1/4, and 2 times 1/4 is just 2/4. They have a common denominator, so we can go ahead and add their numerators. Negative 1 plus 2 is 1/4. Where did I put it? So she goes 1/4 of a foot into the air. So 3 inches into the air. Which is pretty high. And then it asks, when did she reach her maximum height? That's the x value, your time. And we already found it right here. So again, you're just doing your line of symmetry, and this is where, okay, so this is where it becomes a pain in the butt. So your line of symmetry is just negative b over 2a minus, so it's, we already found it, it's 1/4 seconds. And none of it wants to work. So it's 1/4 of a second. Okay? Okay, last one is a ball is thrown into the air. The height h in feet of the ball can be b, modeled by the equation h equals negative 16t squared plus 20t plus 6, where t is the time in seconds and the ball is in the air. When will it hit the ground? So again, you're looking for the zeros. When you're asking about when it comes back down to the ground, those are your zeros. Okay? So, I went ahead and did the quadratic formula. Okay? So, we got, we plug it in, our b's, our a's, our c's, we get that, and we go ahead and simplify. So, we get negative 20 plus or minus square root of 40 plus 384 all over negative 32. That becomes square root of 784, which becomes 28. So now I can go ahead and split it. It can either be negative 20 plus 28 over negative 32, or it could be negative 20 minus 28 over negative 32. So I go ahead and solve this. I get x is 8 over negative 32, which is negative 1/4. Here I get negative 48 over negative 32, which is 3/2. Now, here's the thing. Because you have a negative, and x is talking about your time, you can't have a negative time. So when you think of this graph, it's actually, when you throw a ball, it's not starting from the ground, it's starting from your arm height. Okay? So we're not starting at the ground level there, so that's not where our 0 is. Instead, our 0 would be in the negatives, but we don't care about the negatives because we're talking about time. So we can't have a negative start. That's not right. Where'd it go? So you kind of have to ignore this and start at 0 for the time. Okay? So 0 is the real start time, which means it'll take 3/2 of a second for it to work. Okay? You kind of just need to ignore this x value and go with this one, 3/2. Okay? But that's it. If you have any questions, write them down. I'll go over them next class. But yeah, sorry it was a long video. It's just a lot of stuff. And this is all very, like, I'm showing you every single step, which you guys can kind of condense a little bit. Okay? And not every question will ask everything about the problem. So, write down your questions. I'll answer them next class, and we'll do more practice in class for sure. Okay? Bye!